Okay, so we're finishing section 1.3, inverses, exponentials, and logarithmic functions. And what we left off on was properties of logarithms. So we'll do a couple questions with properties of logarithms. These are our properties that we talked about. Let's do some examples. Right, we went over all of this last class. Expand the following. So we're using the properties above to rewrite our questions. So this is question number 8, I think, yeah? Yeah. So I have the log of AB over C. So AB divided by C is inside my logarithm, right? Once it's inside my logarithm, I can use these properties. Okay? So what do you guys think?
Log AB minus log C.
Log AB minus log C. So you're using the division property. I like that. Who can help me split up log AB? Log A plus what?
Log A plus log B.
Good. Log A plus log B. Can I expand it any more? No, so we're good. Okay, so this time I don't have parentheses. That's fine. I still have to have something inside of the log. What's inside of the log is the square root. So what can I do about that? Good. So I'm just going to rewrite it one more time. What's the power on my square root? 1/2, right? So if you don't need to write this step like Emily didn't, or sorry, like Anne didn't, then you can skip that step. But I have x to the 1/2 power. If I have a power inside of my logarithmic function, right? This x power is on b, not on log. Then I can bring it out in front. So that becomes 1/2 log x. So are you guys feeling good about this? Is this okay?
Very good.
Okay, you guys do this one on your own. Number 10, log of x squared. Oh, let me make it even better. Too much? Too fast? I think you guys got it.
I didn't see that.
Too much? Too fast, you guys?
I was
Sorry. You guys can do this one.
Wait. You're not gonna let stuff from this on a test.
Why not?
You're gonna use this.
What are you guys saying back there?
Actually, that wasn't too far. So we got correct.
All right, who can help me? So what's the trick with this one? Got to break it up. But why are you guys acting like it's crazy?
Because you do everything in one.
Yeah. What do you guys think about the squared here?
It's the whole thing squared. Yeah.
It's the whole thing squared, so I cannot use the first rule on this squared. Because that power is on the inside of log, that's when I can move it out to the front. If that power is on the outside of log, tough cookies. Okay? So who's got an idea? I'm leaving this squared alone because it's log squared. It's not the inside squared.
Okay, I think I got to the end of this.
Okay.
So the first thing I did was I used the division property.
Okay.
So the whole thing.
So are you guys okay with this, or should we do step by step?
Why don't we do it step?
Okay.
Okay. Division property. So it became log x squared y minus log square root of z. And then I just made the whole thing squared. Is that the correct
Good.
way of carrying that?
Yep. So the squared is on the outside, so I cannot use the first rule. Leave that squared alone.
And then it became log x squared plus log y minus 1/2 log z, and then that whole thing squared.
Good.
And then, and this was about as far as I could go. I got to the point where I was 2 log x, so I took the 2 log x plus log y minus 1/2 log z, and then the whole thing was squared. And maybe you can go further, but that was as far as I got.
What do you guys think?
When we're like separating out like the multiplication ones, we don't need to put things in parentheses, do we?
I mean, if you have one thing on the inside of log, I don't usually write it.
Oh.
I don't usually write, if it's log x, I don't usually write log parentheses x. But if it's like...
No, I mean like when you separate up like log xy into log x plus log y, do you put that whole thing in a parentheses because it's making up one thing, or what?
It doesn't matter, because if I do the numerator first or if I do the denominator first, it doesn't matter. Right? Because if I put this back together, if I gave you this question and said, use properties of logs to write it as one logarithmic, you could do the multiplication and then the division. So did we get any further? Did anybody get further? Not unless you want to FOIL this thing, and that would just be real ugly. Right? So good. That's the answer. Okay, what about number 11? What do you guys think? You want me to do some parentheses with this one? All right. You guys write it on your own and let me know what you think. What do you guys think?
We're just trying to expand it.
Yep, we're trying to use the rules above to see how we can write it differently.
Would it be 2 log A plus 2 log B?
What do you guys think? So I'm trying to trick you, and I tricked you. Don't laugh. I did it because it's a very common mistake, and I want you to see it.
Is it log A plus log B parentheses squared?
No.
Is it just
tricked you too?
2 log A times 2 log B.
So you're saying 2 log A times 2 log B. Who agrees with that? A couple of people. So here's the trick, is that I do not have multiplication inside of log. I have multiplication of logs. Right? I cannot use this rule. I do not have multiplication inside of log. And that's why I was trying to trick you. If I have the division of logs, the division has to be inside, right? A lot of people mix up these two, and you cannot combine them. Just like I have multiplication of logs, I do not have the multiplication inside of the log. Okay? So for this one, I can bring the power out. For this one, I can bring the power out. I can say that's 2 log A times 2 log B. And I can say it's 4, whatever you want. Okay, so make sure your multiplication is inside of the logarithmic function.
Oh, now can you do this? I just took the 2 and just distributed it. So I just
2 times 2 is 4.
Put log A, log B in parentheses. I can't do that?
That's what I just said, no.
Oh, no, but not plus, just times. Log A times log B. You see, I just took the 2 and... Can I show you?
So what you're telling me then, so let me see if I have this right. You're saying I can write this as, did you write it as 4?
No, ma'am.
You're saying 2 log A log B?
No. 2 and then log A times log B in parentheses. The whole. So 2
Okay.
parentheses. 2 and then 1 parenthesis log A times log B. Yep. Is that okay?
Well, I have 2 and 2, so it would have to be 4, right? It's like 2x times 2y is 4.
Okay, because it's not addition, it's multiplication. Okay.
Yeah. Okay.
Wait, but would that be correct? To write 4 times the whole thing?
Why not?
Because you have 2. Okay, yeah, that works.
2x times 2y is 2x times 2y.
Okay.
Or 4xy is 2x times 2y. Right? Okay, let's do these ones. Example. Solve. Okay. So how do I solve this?
Why are you saying that 8 equals 1 over 12?
It's x to the 8 equals 112. It's weird.
What is it?
It looks like you have it log to the power of 8 equals, to the power of, and the power is 8 equals 112. That's what it looks like.
So this is log base x of 8 equals 12.
Yes.
Is that okay?
X equals 64.
Okay, I need an intermediate step though.
Log base x of 8 equals 1/2.
112.
Oh, it's 112? Oh, okay. That makes it a little hard.
A little different.
That was 1/2. Okay. Well then, x to the 112 equals 8.
So you're doing the definition of log, right?
Yes.
So somebody once told me all around the world. I don't know, that's how somebody memorized it. Some high school teacher said. I don't know. If you guys have sayings for stuff like that, I think then I start to say them and then it helps people remember sometimes. So that's the definition. This is x to the 1 over 12 equals 8.
And then that's the same thing as the 12th root of x equaling.
Yes.
And then I wrote x equals, or
Okay, so we need to raise both sides to the 12th power. Right? Is that what you're doing?
Yes, ma'am.
Okay. Because 1 over 12 times 12, I multiply those exponents, and that equals 1. So x equals 8 to the 12, which is something ugly.
Right.
Probably wouldn't even go in the calculator. So we'll just leave it as 8 to the 12.
Now, is there a plus or minus element?
What do you think?
Um,
So let's do an example that we know. If I have the square root of x equals 4,
yes. X would equal. Oh, 16. There would be no issue. Okay.
right?
I don't know why I'm thinking that has to be more complicated.
But bigger numbers make people question, right?
Yes.
So you know this one.
Yes.
So try to relate it back. But I like how you're thinking, because if you did the square root or the fourth root or an even root, then it would be plus or minus. So good.
Okay.
But because we raised it to a power and the power was a whole even number instead of a fraction.
We don't have to worry about it.
Right.
Okay.
So if I did square root, fourth root, which is the 1/2 power, the 1/4 power, good. 13. So you're going to see problems like this on the homework. You'll see problems like 13 on the homework. Let me do a little intermediate. So solve for x. So how do I solve if my variable's in my exponent?
Take the logarithm.
Always take the log. And why is that, Reese?
Because the logarithm is the way to reverse exponent.
Because if I take the log, then I can use this exponent rule, and I can bring the exponent out in front. So if you ever have your variable in the exponent, you have to take the log. That's how you get the variable out of the exponent. Okay, one more time. If I'm ever solving something and my variable is in my exponent, I have to take the log so that I can use this rule right here. It's the only way to get the variable out of the exponent. Okay, for this one, it's a little easier though. I have the same base, right? 2 to the something equals 2 to the something. So those two somethings need to be equal, right? Yes?
Yes.
If I have 2 to the 10, I could make these powers anything, right? What's the power on my 2 on the right-hand side? 1. And here my power is x plus 2. So I know because x plus 1. I know because my bases are the same, my 2's are the same, I can say x plus 1 equals 1. These are both 2's, so I know the exponents have to be equal. I can't take the log though. So I'm subtracting 1 from both sides and I get x equals 0. All right, let's do one where we have to take the log. I have 7 to the 3x plus 4 equals 63. Okay, now there's no way I can have the same bases, right? So like Reese said, I need to take the log of both sides. So I'm going to say, we can take the natural log or the log. I kind of like natural log more. So I'm taking the natural log of both sides. Okay, now I need to use that rule where if I have an exponent inside of the logarithmic function, I can bring that out in front. Okay, so what is ln of 63 equal? 4.14 something. Some ugly number, right? Okay, so this is a number. ln of 7 is a number. So even though it says ln of 7, it says ln of 3. Those are just numbers. They're ugly numbers, but they're numbers. So now I have a number times this equals a number. I'm trying to solve for x, so how can I get x by itself? Divide both sides by ln of 7? Because if that was a 2, that's what I do, right? So it's a number, it's an ugly number, but who cares? This is still some ugly number. I don't care what the ugly number is. Leave it alone. Solve for x. So I get everything with an x on one side, everything without an x on the other. So I need to subtract 4 from both sides. And then what? Divide both sides by 3, because I have 3 times x. I'm trying to get x by itself. I divide both sides by 3. Now you could put it in your calculator if you want to and round. I like the exact answer, even though it's ugly. So you'll have problems like this.
So like going back to the like very start of it.
Here?
Yeah, like what couldn't you just put it in like a normal log function with like 63 log base 63 to 7 equals 3x plus 4?
So from here,
Yeah.
you're saying do the definition of log?
Yeah.
So tell me what to write.
So just be log base 63 so the 7 equals 3x plus 4.
Log base 63 of 7
Yeah.
equals what?
3x plus 4. And then can you just do it like that? Would it be kind of easy?
What do you guys think?
Be log base 7 of 63.
Be log base 7 of 63? So let's check this. I have 63 to this equals 7. So this is a little off. So what did you say?
Oh, I said log base 7 of 63 equals 3x plus 4.
Log base 7 of 63. So I have 7 to this power equals 63. Okay, so this is correct. Okay, so then you want to solve this one. Okay, so how do we solve this one? I'm still solving for x, so I get everything away from the x. So I have log base 7 of 63 minus 4 equals 3x. So I'm going to write it like this just for a second. So Anne's saying that these two are the same. Why are these two the same?
Because of the change
Because of the change
of base.
of base. This fraction right here is the same as this right here. So you get the same answer. So that's another way to do it, right?
Am I making the same mistake I made last time to say that you could turn that expression ln 63 over ln of 7 into ln of 63 minus 7?
Yes.
I'm making the same mistake, okay.
So this, if you look at the rules, this is the change of base. This is what we have here, right?
Right.
Not something like, we don't have this.
Okay.
There is not division inside of the logarithmic function. There's division of logs, which is the change of base formula. So that's why these two are equivalent. Good, Liam. I like seeing different ways to solve the same problem. But make sure you've got the definition.
Does it matter whether you're using ln or log?
I don't think so. I mean, if I had a base 10, definitely use regular log. If I had a base E, definitely use ln. Right? Yeah. Because, I mean, even if you had log base E of something, it's just kind of a waste of ink, right?
Yeah.
But because you could always do change of base for that. So, okay. So are we good with this? I like the two different ways. Okay, so that's the end of 1.3.